very good morning to all of you. And I presume I should say good evening for me and Francis. Data science, as you know, is a broad aspect which has come in the market as a boom since it started in 2010. 2010 onwards, it has been going through a lot of revelation as far as the data structure is concerned and the data in perspective. So ideally, when we start with the data science, what we talk about is finding out data which is meaningful and finding out how we can, data science is being used to find out a way we can structure the data, those which are unstructured, and organize the data which is already structured. So ideally, we are taking up this table of content. Today's session would cover a little bit of data science. What is data science all about? Need of data science in defining data structure, the application of data science in structuring and organizing the data in perspective, and what are the tools and techniques used to structure them in for a purpose. It may be a business purpose or it may be a scientific purpose. So ideally, we broadly define it as business intelligence versus the data science, because we have a perspective of business involved in the data science right now. What data has not been structured would actually mean it does not have business in it. However, we are converting the data into a structured data so that we can make business out of it. Business means insight. It means a lot about how we are structuring the data and how we are using it on a instance basis. In this, the next part would be a 5-step international certification in data science. Now, when we talk about the international certification in data science, the first thing comes is that how the certification happens and what are the 5 steps we need to complete the cycle of data science module. So those modules are internationally acclaimed. I've worked with various financial and non-financial background companies. This is completely corporate certifications, ratified and verified by various organizations. When we run a life cycle of a data science, we are trying to find out how and what are those areas which you need to educate yourself so that you become foolproof in managing a data science project. So ideally, the life cycle of a data science describes how you are actually taking it forward to the next level using the life cycle of a data science. It depends on, again, the organizational structure. It also depends on the types of data we use. And it also depends on how we are using those data, in what perspective is the future of this particular data science. So it lays a foundation of how you are actually structuring the data in the data science paradigm. Now, learning outcomes and benefits is just a summary which will give you a broader perspective as to how to take up from scratch a data science project. So we will talk about all these sections one by one. So to start with, we have to start with what is data science. Age-old data which we are actually handling may be older than what you can think, and 10% of the data has been structured and 90% is still unstructured. Who is the person who is actually doing it? The structuring is done by certain algorithms, certain programs, certain procedures. It can be a program, it can be a group of programs, or it can be a model which we try to construct from scratch. So if you talk about data science, it's a blend of various tools, algorithms, and machine learning principles. And the goal is to find out and discover the hidden patterns from the raw materials. Apparently, we think that data is not structured and it does not have patterns. And the raw data which we are talking about walks you through 3 different aspects. One is the computer science IT background, one is mathematical science, or it is called as the statistical science, which we will have a preview of while we are studying this particular data science. And you need to have a very good statistical background. A brief of the statistics, what is involved in it, would be discussed in length. while we are doing the modules. And then we come to the domain or the domain specific business knowledge. It is called as the knowledge which is gathered is intensified if you are structuring it in different kind of domains which you're using it. So ideally, only having knowledge would not have a purpose. There should be a business knowledge which needs to be imbibed in your structural data which you have. So data science is primarily used to make decisions and predictions based on the present and the future. Also, it includes part of the past which has already happened. Based on the past and the present and the future, what we are trying to define, it would basically mean that you are first finding out what happened in the past and what is happening in the present. And these two components taken together would have a prediction pattern. Now, what is the hidden pattern or what is the discovered pattern? We will come to know when we know more about data science. Now, next part is that data.
Christian, I have
Yeah.
a question. So when you say about data science, the predictions and the behavioral patterns of
Yeah.
a business model that we are talking about, so basically with the evolution of data, I mean, as we were discussing about the structured and unstructured, so do you think like in today's modern era of technology, the role of data science is playing huge, I mean, on the end user with the a lot of predictive analysis and cognitive analytics that we're talking about?
That's completely true because we have three primary sources of data here. One is the maximum data which we have at this point, which is unstructured and lies for us to structure, is the social data and the transactional data. The transactional data means it's the banking data or the transactions which are happening in the banking side. It can be a transaction which is happening while a match is being played. It can be a transaction where people are logging in and logging out in millions, and it is in trillions sometimes. So ideally, the machine data is nothing but the data which is stored inside the PC. So ideally, when we are talking about the data stored into a PC, it is machine data. When you are talking about transaction, it is about banking and non-banking structured data, which is being translated from one place to the other. Let's say a bank is in Alaska and one bank is in India. How do they transact? The transaction data comes to us through web, and that is a huge data. It's a transactional data means every day there are 40 million transactions in one single nationalized bank. And these transactions are getting a lot of attention because these transactions are being recorded and has to be recorded because of security reasons. There are a lot of security breaches which happen, and that is what is requiring data science to find out which transaction is being recorded, which is not being recorded, or which is being recorded but it has not been secured. So ideally, which to secure and which not to be secured is decided by these data structures. So ideally, when we are talking about social data is various: Facebook, WhatsApp, and other media structures, Twitter, or anything which you talk about the big data. So when we are talking about big data, it's always a social data and transactional data. Machine data is something which is stored already in the system, but we are not using it very often. So ideally, what I'm trying to say is unstructured data is 90% at this point in the form of text, images, in the form of documents which are not structured and have not been data warehoused. There are certain data which are very sensitive, like the personal information of any customer or any transaction which has happened for the customer with payment. So ideally, a payment which is made is online needs to be super protected and has to be
Yes,
protected
Christian,
from
I have
breach.
a question.
Yeah, yeah. So the next point which we have here in the sheet is about data
Christian,
structuring. Yeah,
Christian, I
yeah,
have a question here.
sure, please.
Okay, as you said that unstructured data.
Yeah,
For example, I'm a startup. Okay, I'm trying to figure given data. Okay, that I've amount of data that I've collected from the last 3 to 6 months.
Okay.
Okay, and I need to predict the the next 6 months according to that particular data. Is that possible?
Yes, it's very possible because we have to structure that data and make it a data warehouse and archive the data in such a way that only that particular span of time is being projected. Once we get the data structured for the past few months, those 3 or 4 months which you're talking, or 6 months which you're talking about, would be stored in a structured manner, and we will have an analysis on it. Based on the
So,
analysis of the past, we will have to predict the future. It is
so
always, as I, it is
no,
the present.
no, to what extent that we can predict is what my question is.
It is again. It depends on what you define as the range of prediction. Now there are several ranges of
And
prediction.
and also,
So we
what is the
define the
percentage
prediction.
of accuracy? What is the percentage of accuracy?
Yeah, the rate of accuracy reduces as the data structure or the data span increases, and that is where the crux. The point is that the stored data which you have a huge range of data, and then you are predicting a huge range of data to the next level or the future. What happens
Mhm.
is we need to percentile them in this particular span. Let's say you have a 6 month span for the future. You'll have to always fix the span so that you can make the data interpreted according to the need of that particular data structure. So ideally, the span of the data, or you can say the limitation of the data, need to be firstly ascertained, and then we can go forward and interpret in an accurate way, because there
Wonderful.
is a lot of information which is coming in. Suppose there is a big amount of information, we need to create a data warehouse so structured that it will have or any span which we can think about. So ideally, there is a vast amount of data which is being aggregated. Our data science is doing a huge work of a mammoth. In fact, a mammoth data cannot be structured by usual data warehousing used by Oracle or any other company. What we are trying to say is all those structured data need to be aggregated together, and we'll have to make a span of time for the future to find out that unstructured data to be converted to a structured data. So ideally, the interpretation depends on the vastness of the amount. If it's a vast amount, then it will need a smaller span or a greater span, which is ascertained by the vastness of the amount. So effective decision making will be defined if we are spanning the time or spanning the time to the future. Now, if you talk about 6 months data and then you are trying to predict 1 year, it will be inaccurate for sure. But if we divide them into parts and then try and predict them one by one, or maybe a percentile of the data would actually be structured, and then we will go forward moving data integration. So ideally, this data integration, but it will have a range of data which is effectively decision that this is the range we will work on. Let's say we have a quarterly report, we have a monthly report, we have a half yearly report, and we have an yearly report. All these four sections will be catered by this particular data science structuring. So ideally, if you want the data in a year, it would be a vast data. So the accuracy would actually be lesser. In fact, the precision which you would find out would be the range of the data. If you lessen the range of the data, and the vastness of the data would actually define better precision, because we have a lot of data which is actually giving us a better percentile at the end of the day. Okay. So what we are trying to say is more the data, the better is the accuracy on the efficiency of this particular decision making. So the efficiency of the decision making would be better if you have large data structured into smaller span of time. So ideally, that's the point here. So structured data we already have, unstructured or semi-structured data we are trying to build, and we are building on it. We have around 60 to 70% of it is semi-structured, and the rest of that is structured. So the structured data is very less, it's 10%. And semi-structured is right now standing at 30%. Rest of them are unstructured. So we have a lot of work of a data scientist to come up with a structured format. So ideally, we have 90% of the entire group of data which we have need to be structured, and we need in the next one decade, we would need precisely 3 lakhs to 4 lakhs data science graduates who can actually structured unstructured data, because unstructured data is something which is not at all in picture right now. The format is not fixed. We don't have any way how we can structure it. So we need to make algorithms for them. The very precisely the algorithms which we are talking about is nothing but structuring the data as an algorithm. And we need a data scientist basically to find out how we can structure the data. Okay. So
So, Bishan, I have a question here for the data structuring. We are looking at the data structuring here. So, as you convert the 10% of, uh, because right now all the data, the 90% unstructured data has to be converted into the structured data. So, the role
that's
of a
right.
data scientist becomes very, very important to convert that unstructured data, which is not at all structured. So, according to you, uh, right now, for this particular mechanism, the data structuring, do you think something like a MIT, which is they normally use it on the Hadoop ecosystem, which converts the data from a unstructured to structured, do you think such kind of mechanism will
Absolutely.
add more dynamics?
Hadoop will be the best because big data Hadoop has been revelation of finding out unstructured data, a volume of unstructured data, vast volume data which you have. I think will be effective on Hadoop platform. And when we are talking about Hadoop and Python programming would actually come as an amalgamation. It would be a combination of both. And when you're talking about Hadoop, yes, it can take up the unstructured data, convert it into structured data. When once we construct the or structure the data, where would it store it? We have to store it in a platform, and that platform should be a cross-platform. It can have a cross-platform uh, uh, sharing method. Suppose we have a sharing method. How do we share it? What exactly should be the unique platform which can be used? I think Hadoop is the best in the market, which can actually share anything and everything which is required at that particular point of time. And that is why Hadoop has been very powerful and will be powerful in the next 10 years for sure.
Wonderful, wonderful. Thank you so much for that clarification.
You're welcome. And how now? Let's move to the next part of a very important discussion here. I need your participation in this and your perspective as to what you understand by these steps which have been mentioned. The 5 steps, data science, how it works and what it does. Very importantly, we forget to understand that the problem formulation is the essence of finding out how we will proceed. Let's say if a statement can be in the form of a statement, it can be in the form of an operational analysis. Let's say an estimate. It can also have, you want to predict or estimate something, you need a problem statement. First up, you need to have a formulation of a problem. What is the problem? It's just a statement that my computer is not working. Next, what is the next part? Obtain the data. What is the data you need? Why is it not working? There might be a hardware problem or a software problem. Very simply, what we are trying to infer is to obtain us data which would be clean and would be privacy. There would not be any privacy and security issues with that particular data. It's not privacy sensitive or security sensitive data. Ingest the data and transform the data. Very importantly, when we are transforming a data, we need cleansing first, and then it comes to transformation. So ideally, clean data would give you better outcomes rather than unclean data. So what is cleansing? In fact, will be very clear in this part, because if you obtain a clean data, you are ought to get the best of the output which you want, and you can explore the data or plot the data on a very good pattern. So ideally, finding the patterns or anomalies depends on how clean the data is. Data cleansing has been the pinnacle of how we are starting with the problem. Let's say we have a problem and we don't have a clarity of what the problem and what is the solution. So ideally, finding out a solution needs a clean set of data so that we can find out the outcome, or we can find out the solution for that particular data, the problem which has come. Now, plotting the data means it is part of the analysis, but it is not analysis. It is finding out similarities between data, finding out a similar kind of analogy between dissimilar things. So there are certain dissimilar things which we need to patternize. There can be certain preferences of the customer. Let's say we talk about the customer, they have different preferences, but we can group them into patterns, or pattern of buying. Let's say if it's a pattern of buying, the person is always in formal wear. If the person has a preference, we'll have a group of people who have this similar kind of preferences. So that's a pattern. So ideally, when we are identifying a pattern, we need to have the data behind those patterns. So ideally, plotting the data according to the pattern is very important. First, find out the pattern, then plot the data according to the pattern.
What you mean in simple words is sorting the data.
That's right, data sorting. Sorting the data is done in Excel. It is done in other like R and Python uses the sorting methods to find out this discrete data into concrete data. So ideally, we are constructing the data or plotting the data and mapping the data according to the patterns which we are trying to find out. So ideally, once you plot, that's when you can find a pattern. Without plotting, you cannot find a pattern. As simple as that. Let's say we have a group of users who are using only certain frequent things every now and then. In a month, how much did they buy or how much did they utilize? That is again a pattern. We are trying to search a pattern, and then we are making them in one group and finding out their preferences and publishing it. And then there comes the building of a model. So ideally, which model fits to which particular set of patterns will be decided by the data plot. Now, when you plot the data, the building of a model depends on how it fits to that particular data pattern. Now, that pattern which you have chosen cannot be changed, and that is the essence of the model of the data. Why do we need data modeling? Because we want to validate the patterns. We want to find out the best fit for the patterns. Let's say you have a preference of songs which you play on YouTube, and when you are trying to build a model, it means you are customizing the customer to hear similar kind of songs every now and then. So it's modeling the data. That means you are creating a model of that particular pattern, and then you are presenting it and validating it that this is your best choice you have. In the next 5 days or 6 days, you will find only those kind of songs coming on your YouTube history. So ideally, this is nothing but we are trying to make sure that we build up a preview of an insight. So a preview of an insight is made in the modeling of a data. So ideally, we try to make a product. Let's say we are making a dashboard. Before that, you need to have a model, a best fit model. To validate that model, we have a structure. So that structure is being made by the modeling of the data. Now, the last part which we have is the most important part. I would have a better understanding in the next slides which I have. I would show you the 5 steps which are studied while we are doing the same data science as it works. So insight here means it is the use of the dashboard of a customer. Suppose a customer has used in historic data, customer has used certain things and he has missed out of certain things. We can convey that particular thing in a visualization tool. With the visualization tool, what happens? We are trying to visualize which you've not used, which you've used. What was your pattern which you have not utilized? What was your pattern which has been utilized the most? So ideally, we are trying to visualize and analyze the thing and putting it as an alert message or any message which would make you alert that, okay, these are the things you've not used. maybe you can try this time. So it's conveying a message, giving a visualization, a broader visualization of even when you don't remember your preferences, it will make you remember, okay, you chose these things and now you have these things remaining. Are you able to choose out of them? Then the alert message comes. So ideally, once we are trying to set an alert, we set a job alert. Suppose, let's say we have a dashboard which has a job alert, which is very much synonymous to what we are talking about here. We are building up dashboards on the go, and a person who is job hunting would actually hunt only specific jobs. Ideally, it gives you an alert message each time, every day, on your dashboard, that these are the preferred job sets which you were asking for. I have it. These are the recommended jobs which you need to apply for. So ideally, this alert message, what you get is nothing but a dashboard or a visualization tool. So it's a visualization to find out how you can actually be better than what you are right now. So I think this is very exciting science which has come in work. Python, Excel, and Tabuli and R are the best of the lot, and the simplest of the lot would be Excel. It's better to start if you are a starter, or if you are someone who can't handle too many applications. You would definitely choose Excel out of this entire patch of things which you see in the picture. So Python is the last you can take. Second you can take is after Excel, you go to R or Python. Based on your data structure which you're dealing with, you will have to also use SQL sometimes, and Tabuli. Tabuli is very useful software. However, there are certain constraints. We will come to the comparison in due course of time. We will know all these packages one by one. We will have a broad overview of which can be used when. So if you are in the service industry, or you are pertaining to changes, you want to record the changes, you will have to work with these tools very often. And that brings us to the exciting journey of the next slide, which talks about application of data science. Now, applying data science, it has been applied anywhere you can think about. In internet search, the best example of the optimization of data. If you talk about the market optimization, I think Google has started with the digital era, and it has been taken up by AWS. It has Amazon has taken it up, and Netflix has taken it up. However, we have other sections which I can name them. The main areas of data science algorithms which you are dealing with right now, they are defining the domains actually. The domain is internet search. Second is fraud detection. Third is healthcare. Fourth is weather predictions, transportation, and sports. Fishing obviously is something which you don't do very frequently, but I can tell you people in the ocean would definitely want the identification of the precise fish or the fish they are looking for. So ideally, it's really very exciting. Image recognition has been one of the best in the Facebook. If you talk about the Facebook recognition algorithm, has been an award winning, because you can tag a friend at any point of time. Automatically, the tag suggestion reflects on the friend's Facebook page. So ideally, you don't have to get a suggestion of friends, it automatically comes to you. So it's full automation of a feature of Facebook, which is built by a face recognition algorithm. The moment a face comes on your camera, you are connected to the Facebook, it would actually take that image and try to match with the profiles which it has in the Facebook flood. Now, in the entire pond of Facebook, you will find one image which is similar to this. So it will try to connect with the features of that particular user. Now, that user gets connected automatically. Let's say I lost Joshua and I found him on Facebook again. So it's been 10 years or 12 years I have not met the person. I just took a pic of that person. I tried to pick up that picture, and then that picture is actually suggesting, okay, this picture belongs to this Facebook account. Are you a friend of his, or are you tagging him as your friend? If you tag your friend, the moment it does, there's an algorithm which recognizes the face, and the Facebook prompt comes in as a friend invite. So ideally, this is magic. This is magic. And gaming, let's come to the gaming section, which has come as a biggest breakthrough in the next level gaming systems, where we have
Before that,
different.
before
Yeah,
that, I have a question, Bisham.
sure,
You know,
sure.
uh, say what would you say if we are still following the old-fashioned what to say Excel format,
That's right. Yeah,
right? To sort out the data and stuff like that, right? We get real-time data and then we convert it into Excel format, and then we try to figure out a certain particular what to say uh, what to say uh,
pattern.
pattern, yeah, a certain pattern, right? So what different is it, you know if I'm learning data science, how different is it going to be, in sorting out those things, in
Yeah,
terms of
definitely.
business?
Uh, Even I just want to say this, that Excel is the start of the data science is also involved in Excel sheets. Right now, the Excel which we have, the version of Excel which we are using, can also be connected to R, can be connected to the Python structured data. Let's say what we are using Python and the other data science tools is to find out those data which you have in Excel. Can we make it more colorful? Can we make it more useful and motion specific? Let's say we have a data structure which is directly coming from an Excel sheet, but we
Right.
don't have the visualization tool which can actually visualize or cluster that data. So data clustering is very important. If you cluster the data, that's when you can visualize the data better. So it's a group of data which used to go into Excel sheet is very small. However, if you want to make an algorithm and attach it to the Excel sheets, it can actually attach 1 million Excel sheets together, which is not possible at this point in Excel itself. But if
Yeah.
we embed these two tools in Excel, that will give you a dashboard which is mind boggling. I would say
Okay.
it would give you a lot of dynamism. It would also give you a lot of experience as a customer if you want to visualize your
So you
transactions in. Yeah,
So you're meaning to say, okay, if I have a prediction, okay, these many calls. So for example, okay, I have an inbound call center, right?
that's right.
I have an inbound call center, and I'm
Okay,
predicting there would be close to 3,000 calls today, for today,
that's right.
being handled. All right. So, what is my staffing? What is my staffing for that
Absolutely.
particular 3,000 calls? Okay, what is my staffing, and what has been the pattern in the last say 3 months? Okay, what has been the last 3 months staffing pattern, and what it is going to be now after I have integrated your solution like data science into my project. Okay, so
Absolutely. Let me share with you a story, a small story of a person who was boggled by the way the things have happened in a call center. He came in with a suggestion, okay, can we have a dashboard? How many people went out, and logged in? And in a day or in a month, how can we actually structure this login and log out? And how can we connect this to the calling system where somebody logs in and somebody logs out? There's a timeline. So as it works 247, what we need to do is to find out the number of inputs and number of outgoing people. So ingoing and outgoings were calculated, and they came up with a dashboard that these many people will be coming in the login, and the prediction happened in such a way that we are going to get 30,000 calls today. We have these many people's shot. We are falling
right.
short of many people's. So that prediction is very important. I think that is the breakthrough. That is what is improving the structure. And I think this would be the essence of data science, and it would give you a breakthrough of finding out backlogs, finding out people who have not taken up calls, sleeping on calls. Everything gets automated. In fact, everything is becoming recorded, and it is being archived in certain data warehouses where it has been structured and it cannot be changed. So there are unchanged structured data, there are changing structured data. So ideally, the changing structure data would actually be a meaningful structure here, because we need live data. We need something which is happening now. Let's say we have a login from 6:30 in the evening to 3:30 in the morning. 9-hour shift. We have 50,000 people coming in, and we have 2 lakh calls to take up. Now,
Okay.
this scenario, in the scenario, we understand these many people are not coming. That means we will have to backfill someone or call back someone from the early shift, and then we'll
Yeah.
have to feed back these number of people. This is the man hours we are missing. These are the man
Correct.
hours which we are missing. So organization, as an operational manager or operations manager, you would definitely want to know how many people we are short of, and how
Yeah.
can we backfill that particular number of people, and we
Yeah.
can make it up.
That is exactly what I'm. That is exactly where I'm getting to.
Thank you so much. So ideally, you understand this. This is a breakthrough, and when we create a dashboard like that, it is dynamic. It is picture. It's like a visualization, colorful. It has lot of dynamism. Wherever the data gets changed, it starts changing. It is 3D also, three-dimensional, and we have three-dimensional structure of visualization tools which has come in with the help of R. We can actually put a stop to these things. Certain things which are happening in the process would be predicted, and if there is a theft to be predicted, the best example I can give you for fraud detection. In the fraud detection, there are financial frauds which are happening. Data warehousing has been doing it off and on in the banking sector, but data science has come up with a breakthrough called as we know, blockchain has come in picture. So data science, data structuring is very important before we go ahead. So data cleaning is very important before we go ahead and feed it into the banking systems, because
Right.
once once we are talking about blockchain, this is a continuation of technology. So data science not there, blockchain will not work. If data science is there, blockchain will work better. So
Okay.
that's how the dependability of technologies have become, and that is realization of the companies as an organizational structure. Everything has become data driven, because we need proofs for fraudulent transactions. If you don't have conclusive proofs, we cannot catch hold of miscreants. And that is what is the essence of data. Now, let's move to the next section.
So, Bishan, I have a question. Basically, when you say about data science,
Sure.
so the kind of techniques that we are using, like there are so many algorithms we are talking about,
Sure.
deep learning, machine learning, TensorFlow, and then you have different Python libraries like Pandas, Matplotlib for the data visualization. So, coming, I mean, from the practical point of view, for the data science, because you need certain techniques. I mean, so according to you, I mean, as you have been already training the students, what do you think Python versus R? I mean, which one is more useful in terms of data analytics? Because R, we
I
know it
think
is mostly used for statistical analysis, but according to
that's
you, what do you think is more beneficial for whosoever wants to build their career as a data scientist?
I think Python will be more versatile and long going, and it has been one of the aces of data science, because it has a leverage of giving you any unstructured data to be structured. So ideally, R is has a very good catch on statistical data, but it when it comes to unstructured data like weather forecasting or anything which is like transportation, route mapping, and all these things, these are versatile things which is being headed over by Python. I would suggest, as a student, if I am a student, I would always go for Python and R a little bit wherever it's required. If it's a statistical data, I will not shy off learning R, because they are two simple languages. They have their own streamlined domains which we can stick to. But if you want to be a versatile algorithm maker, I would suggest Python.
Okay, and my next question is basically we're talking about like artificial neural networks nowadays.
Right.
So in the artificial neural networks where we are teaching the computers how to see, so do
Hmm.
you think, I mean, this Python would be more useful to do those analysis and those algorithms that can help to predict?
It's simpler. R in one stage, we thought that statistical data, it can also go for the image transmission or image sensitivity. We were trying to make sure that we have certain algorithms, but it is falling short. And Python is coming up with a lot of new, I would say, library structure which Python has. I think it is various and it is
Uh, bec-
versatile.
because as you know, one of the key active areas of any kind of research in neural networks is the image classification.
Absolutely. The image classification is the most modern neural network projects which are going on in Massachusetts Institute of Technology. They are coming up with a project which is based on neural network used in image sensing. So ideally, when we are trying to put an artificial eye into a human body or something which you need to make a blind have their vision, I think this is breakthrough. This is the breakthrough, and Python has done a lot on in these. It has gone much ahead of R. I would say it does not have a very. There is a very thin line between the two, but yes, in this perspective, if you talk about neural network, Python is the ace, and it has gone way ahead of R at this point. I've handled both, so I know how it is, how difficult it would be with. We can construct it with R, but it is a time-taking factor. It's much easier for people who are working in this line with Python. They can build up in no time. I would say algorithms built up in no time and has been utilized in computer sections where the AI has gone to a next level where a vision is given to a person who is not able to see, would be able to see with the help of AI. Okay. Thanks to
Okay,
Python.
thank you, thank you.
Thank you for raising this question because it's very exciting and it's a new chapter in data science. AI and ML are the essence of data science, which has gone a next level altogether. We'll definitely cover the neural network in this section of discussions, and you can come up with questions later on. Okay,
Bhushan, I really appreciate every effort that you took. It was really helpful for us to understand. Thank you so
sure.
much.
You're welcome. You're most welcome. Let's move on to the next part of this particular section is the data science. How will you certify yourself or how would you plan your professional life after learning these many things? Are you able to use it in your professional background? Are you able to complete certain certifications which would actually mean a lot? Because while you are taking up any project, they would definitely ask you, are you certified data science professional? Are you certified from somewhere? So this is the first question any student would actually come up with, and any lecturer or any person who would ask would need these certifications. There are levels of certification. They are one in five, and you cannot bar them as the functioning of this entire five step. So we will go back to the five step which we had in the past. Remember this, please remember this part and then try and relate this to this part because it talks about data analysis fundamentals first, then it goes to application of data analysis which talks about the use of the data, then it goes to modeling, data modeling, and then it goes to predictive analytics, which has a little bit of statistics which you need to study. Again, I don't want people to be a master in statistics, but yes, mean, median, mode, they would be able to know it. They have covered it in maths. People from the engineering or non-engineering background also are coming up with this chapter. So there is a small chapter of statistics involved in forecasting and predictive analytics. And the most interesting is the fifth one, which is data visualization. I call it as data storytelling. I defined this as data storytelling because it leaves a lasting impression in the person's mind because every data has a story. If you talk about data, every data has a story. And if you have the underlying story defined, I think that is visualization. So any meaningful data which you're trying to visualize, if you're able to visualize instantaneously at that point of time, and you are able to predict the future in the visualization tool, that gives you the outcome. So your output is nothing but the data visualization tool which you're using, and there are various tools we will discuss in due course of time. These 5 steps which we have has individual certifications as well, but no one can actually separate them. It's 1, 2, 3, 4, 5. We cannot mix it as 2, 4, 3, and 1. We cannot do that way. We'll have to go step by step, and data analysis, application of data analysis essentials, then data modeling, then forecasting, and then data visualization. I usually end the session with data visualization activity, which is very activity based, because I want everyone's story to be data visualized. So,
What are the 5 steps that you said just now? I'm sorry.
sorry.
Sorry, Bishan, I missed out on that 5 steps. What are the 5 steps?
The 5 steps are data analysis fundamentals,
Okay.
application of data analysis essentials, data
Okay.
analytics modeling, and
Okay.
fourth is forecasting and predictive analytics, and fifth
Okay.
is data visualization. In these 5 steps, we have individual projects to be completed. We will have examples, ample amount of examples in these particular 5 sections. The most interesting would be the last, the fifth, because data visualization tools will be introduced. How to use those tools with the present day data which we have, and use cases and test cases will be shared with you. And these test cases are like tests for you. You will have to come up with a data visualization document, and you have to do a dramatic presentation. So ideally,
Uh,
participants would do a dramatic presentation based on their case study. So each one of them would be given a case study and find out a data visualization tool and then depict it live in the form of a PowerPoint slide. It can be in the form of an visualization on Power BI. It can be on Python. It can be on R. Whatever
mm,
tool you choose, you will have to visualize, show us the visualization dashboard. Okay. So that's what the extent of this certification is. Any profession, when you are certified, you are respected, you get a better kind of package, you have a lot of things which you can learn from these professional use cases which are used across domain. We'll not stick to one domain, we'll share all domains what we talked about. Domains in specific would be internet search, fraud detection, healthcare, weather, transportation, projects. All these come in the form of use case. Okay,
wonderful.
so ample amount of coverage on the structured and unstructured data which we will handle in due course. And let's go to the real-time certification. I've just given you this 5-part certification. We have to formulate, if you talk about the data analysis fundamental certification, how to determine a data transformation or a digital transformation. Is it a disruption? Is it a disruption landscape which you're creating opportunities, or are you entering into the organizational ecosystem and finding out the troubles or the problems which you have in the day-to-day life? So, how to make it data driven, how to find out a solution out of the problem statement, and in the data life cycle, we will have to implicate the data as a data driven decision making engine. So, we will have to make an engine which is data driven decision making engine. Now, the next part would be the part two, which we have already discussed about the data analysis applications or tools which we use. So we'll have a lot of statistics covered on this. The second and third part deals with basics of statistics and data profiling and data cleansing. So ideally, basics of statistics like central tendency, classifying variables, measurement of variability. Measurement and variability is something which we need to learn from scratch, because there might be people not coming from the engineering background. I take it into consideration. When I go forward, give him the basics, how it was in 12th standard. After 12th standard, what was covered in standard, let's say in engineering first year, second year, and third year. There are computational methods, there are classification of variables, there is variability and measurement. What we studied in engineering will be actually covered in a very short. Ideally, what we are trying to find out is modeling. If you talk about problem solving or analytics, this is what we are doing. We are trying to profile the data. The available data is being profiled, cleaned, and then presented. So ideally, forecasting would mean that forecasting and predictive analytics certification, we identify the different techniques of predictive analytics like regression, classification, clustering, optimization, and simulations. These are big words, but yes, these are the 5 things we need to learn in forecasting and predictive analytics. Unless we know these theorems, we will not be able to use a regression algorithm. We cannot create a new regression algorithm using R and Excel and Python. All 3 of them will be used. Applying classification and clustering algorithms means we are trying to classify and cluster things into one single data and try and visualize it using visualization tools.
So, Bishan, I have
Good.
a question for you. So, what is the difference between data mining and data wrangling?
I'm sorry.
What is the difference between data mining and data wrangling?
Data mining is nothing but we are trying to find out certain similar data which we have. Let's say we are penetrating a data and finding out specific patterns between the data. That is called data mining. And data wrangling is something which we are trying to tease the data and find out the future of the data. Let's say if you want to find the future of the data, you need to know the present and the past, and then you can predict the data future of the data. So
So,
ideally, data rank.
according to you, I mean, can we use both Python and R to do that, or what do you recommend? What's your
I
take?
think Python is the better tool to use when it's data wrangling, and Python and R both can be used in data mining.
Okay.
Okay.
And what is the trifactor used for?
I'm sorry.
Trifactor. Trifactor, when we talk about machine learning, right?
Yeah.
So there is something called trifactor. Have you heard of it? Trifactor utilizes the techniques in machine learning, like data visualization, human-computer interaction, parallel processing. Have you any time heard of it? That it is data wrangling trifactor.
Yeah, Trifactor is actually a software which was founded in October 2012. It started with data wrangling and data exploitation. It's self-service. It is a self-service data preparation tool, which is used mostly in British nationals, and they've been using it a lot for finding out how we will build up effective dashboards. Let's say a data preparation you need for a certain open source data structuring. If you want that to happen, I think these are nothing but the shapes and sizes of these particular data wrangling which we need. It covers more spectra in terms of trifactor wrangler. I think I have certain things which I will cover while I am covering the part of visualization
Okay,
tools.
okay.
Okay, so
Yeah, thank you for the explanation. Yeah.
you're welcome. And let's move on to the next slide, which is talking about the data lifecycle, which is the essence of data science. If you know these terms, these are the terms mostly used in data science and need to be known to core as to the cycle of data science starts with a business understanding or the relevance of questions or definitions which we talk about. Let's say there is a problem statement. You can't question the problem statement. You will have to find a solution to it. Now, once we start the business understanding, we will have to tackle these questions or problem statements and make a solution out of it. So what is the solution? It is nothing but the data visualization will give you the solution. So communicating with a finding or predicting something, you will have to data visualize it to the for the future. Now, if you talk about understanding the problem statement, the first step comes is the what we call as the data mining. Now, once we talk about the data mining, I'm sorry, I lost this slide. Okay, so data mining is nothing but gathering of meaningful data and necessary data at that point of time or that problem statement. So it is revolving around the problem statement which you are trying to tackle. Now, this problem statement has certain data which is needed to drive so that we can find a solution out of that particular understanding which we have about the problem. So
Mm.
first understand the problem, gather the meaningful data information or information which is specifically focused on that particular problem, and then clean the data and then explore the data. It is just like exploring the problem statement. Let's say we have a problem statement, we might have n number of solutions. Which is the best solution you are going to analyze on that? That is called data exploration. Data exploration is nothing but an hypothesis, which is giving the best solution of the problem which you have faced at this point of time. Now, once we do this, the next part is feature engineering, which is very important feature to construct a meaningful ones using the raw data which you have. Let's say we have cleaned the data, but we are not able to explore the viable solution, which is at this point of time the most cost effective and maybe the breakthrough of this particular organization. That comes in feature engineering. Feature engineering is a very sensitive point where we decide or decision making is done. Before that, we need a prediction. Why we are instinctive. Human is very instinctive and are predictive too. We can also predict our future, but what is the use of machine learning in that way? Why we do have this machine learning tool with us? Because we are not able to recollect that much as a machine learning does, because it historically creates a big structure of data which you can't imagine in your senses. I mean, it is better than your brain, I would say. Your brain, you can use 10%. You can use at a time. Einstein used for the whole life, he's used only 10% of his brain. Can we use 100% of our brain? We cannot. But machine learning has given us a provision by which we can collect the data which is equal to 100% of your memory system what you have. It gives you 1,000 times the memory, and it gives you all that data, and predictions become more easy for you to evaluate that particular system, and system performance is enhanced by the outcome which you come with that particular problem. So if you can mitigate the problem and find out n number of solutions, out of that the best viable solution is given by the predictive modeling, and that is what is the essence of performance monitoring. So once we call about the performance monitoring or the performance enhancement, how do we do it? Because we don't have predictions. We have limited amount of predictions which we can do instinctively as a human being. But if you use machine learning, it amplifies the number of options which you have. You might have had 10 number of options. Now you have 10,000 options. Now these 10,000 options, out of that, you will have to filter down, and that machine learning does. And it evaluates and gives you the best 5 out of those 1,000. And that is the essence of visualization. So the data visualization is so precise that you don't have to search for your stakeholders. It plots you the stakeholders with the visualization that these are the stakeholders who has given you the maximum profit in the last year. Are we going to partner them? Yes, we are going to partner them because they have given us the maximum output. So ideally, we are talking about output in business. If you have a business understanding, you will always talk about ROI, return of investment. So when we talk about data visualization, return of investment on data visualization has been the best part of a business to prosper. How can a company become a unicorn? That is the essence of data science. Data science has given us a prediction that this company is going to become a unicorn in the next 10 years. How? That is given by the data visualization. So ideally, in this life cycle of business understanding, we are trying to find out a way how we can shorten our period of finding out the solution. So when you shorten the period of finding out the solution, it fixes the solution in such a way that it is profit oriented. It is also the best viable solution and agreeable solution for that particular problem. Okay. So ideally, what we're trying to say is data science has given us a lot of flexibility, and also in terms of giving us a brain inside our brain. We have a brain which we can't use more than 10% or maybe a 5% or 1%. Some uses 5%, 6%, 1%. Let's say somebody does not use it. Even if you don't use it, machine learning will make you do it, and it will give you that output. So any novice who wants to go for this model would actually think, okay, I'll not use my brain. I'll not use Um,
A
in,
person like me will definitely not use his brain.
I'm sorry.
A person like me will definitely not use his brain.
Okay, so I'm talking about people who are, there are two kind of people. One person who is very critical about the business transactions or the
Right.
business perspective, understanding the business. And one person is literally a novice in understanding the business. Both of them have way of data science life cycle, and they will get the precisely the same output as you need in that
No,
particular instant. Don't have
what
to
I
use
meant,
your brain or
no,
spend
what
your brain.
no, what I meant was, okay, I'm now totally dependent on data science. I don't use my brain.
That's a very good suggestion. I would say depending on data science would actually mean that you are depending on a machine. I am
Yeah.
still reassuring the fact that instinctive decision making of human beings will still persist, because even if it sees the data saying that no, don't go that way, go this way, the human will always do the mistake. So
Yeah,
ideally,
definitely.
there is always a way of taking up. Again, I don't want you to rely on exactly what the data science predicts, but yes, definitely the predictions are much accurate in terms of finding out solutions, number of solutions. Now, which solution you want to take, it's up to your choice. This is human brain. So
Uh,
never ever did I say that data science or AI will take over human beings.
No,
It
if
has
you
been,
told,
scientists say that AI will take over in the next 50 years. AI
yeah,
is going to create human brain. Is it true or false? It is. It is. A data science graduate asked one of the scientists, "Are we going to create a brain?" He said, "Nah, just wait for 2050. It's going to come to us even better than brain. We'll have a module of brain which is 100 times better than our human brain. Even
only if
then, this
it's
is
connected to the
again,
heart.
so, Bishan, my next question is basically I just want to add to what you guys were discussing. So now
yes,
is data science again is it a myth or a or basically we are talking about a reality? Because right now
we are
everything,
talking about dire reality. We are
yeah,
talking about dire reality, which is going to come to us. There's a
yeah.
competitive component which is being mentioned here, that AI will not supersede human brain at any point of time. There is a regulatory compliance issue which comes into our society. The society will not allow us to have artificial brain when we already have a brain. That's not possible. So ethical sense, if you talk about ethical production of data science products, predictive analytics is really a good chapter. But again, if you talk about AI and ML, I don't think AI and ML is going to supersede human brain, because superhuman brains will not be produced because of ethical issues and
Yeah,
ethical. As you know that ethical hacking and unethical hacking is happening. So the same way, ethical AI and unethical AI would always be separated. And we will have strong regulations, we will have strong rules which needs to be made so that the human brain and the AI don't compete with each other. It is
don't
always, there's full stop
don't
made.
don't supersede.
Yeah. So that regulatory compliance is being regulated by the consortium of AI and ML scientists. This consortium is working on regulations of finding out where we should end in this machine learning models which we are making, or algorithms has limitations, will have limitation, will have to be put on limitation so that it does not supersede the human brain. So
Wonderful.
that this is again something which has come up very recently in AI. There is a discussion which is going on in MIT, and it is being constructed. There's a consortium already in place which is regulating this act, and it will be enacted in the next 25 years. And you will see it very soon in US to be implemented. Slowly and steadily, it will start to all other countries.
So, Bishan, I mean, as you have already pointed, because the human brain and we're talking about artificial intelligence, machine learning, but do you
Sure.
still think that with the introduction of data science and all these techniques, modern techniques that we are talking, because at the end of the uh, term, I mean, we are talking about the future. So nobody
Yeah.
has predicted what 2020 or 2050 is going to be. So basically, with all these techniques and all these algorithms, and with the introduction of machine learning, and now also we have something called robotic process automation. I think you might be aware about it, the RPA.
True. Absolutely.
So
Absolutely.
and
RPA. RPA.
so, what is your observation? I mean, uh, because human brain, I mean, basically, it's the DNA of our mind, right? Do you still think we'll
That's
be
right.
controlled by the robots, or still, I mean, we have some chance
That,
to
that
to
that's again something to debate on this, because that is what the consortium is working on. RPA is fast moving, and it has come to India as well. As you know, HDFC is already having robots to answer your questions. In the premises of HDFC, you will find robots. So ideally, this is not going to be a ritual. Yes, definitely, wherever there is an insane kind of situation where we need robots, like inside an water boiler, or it's steam boiler, or anywhere the human would not be able to reach, those points would be used by the robots. And I would say this is ethical. Again, unethical act will always be there in the world. There are many unethical acts which are going on in at present, but superseding that, yes, definitely we have the fear of finding out a way how we can actually combat with those artificial intelligently built brains which will come in picture. And it has to be used in only special cases where we don't have brain to be used. Let's say if you have a situation where there is an inhuman thing which is happening and you need to destroy that, we need something superhuman. I would say that is a blessing in disguise. I would not say it is going to come to us as a danger. Please don't fear, because we have humans still. We can stop that production of AI. We still have regulatory compliance which has already been implemented by US and will be enforced in other countries. Like blockchain was not accepted by many countries, but now it's being accepted by countries. Why? Because we need ethical transactions. We need ethically produced transactions which are not frisked, which are not manipulated. So we don't need manipulated transactions. We need crystal clear and perfect transactions. So
So
that is it.
about the DRS system that is implemented in the cricket match.
Absolutely. That's the best example of artificial intelligence. I
Yeah.
mean, you can't predict. It is very unrealistic when you get a person out when the umpire is right on top of the ball. He's viewed it. He's seen that it's going across the leg side, but still the DRS system gives it out because half of the ball is showing up on the wicket. So
Yeah.
I don't deny the fact that there are misnomers in the discoveries which we have. This is one of them. I would say the machine learning, we do not rely on completely on machine learning. We should have our instincts. The human instincts even has a science to worry about. I don't think we should worry about the machine learning and the AI which is coming on our way. Okay.
Yeah.
This is actually told by one of the scientists who is working in NASA with the
Okay.
artificial intelligence. They are trying to make a robot so good that it will actually run. It will fly on its own and come back to Earth. That is not possible, but it will be possible by the next 10 to 15 years for sure. There will be a space station where people would go there and see robots actually serving you some delicacies. So ideally, that's going to happen, and it is really good that
Wow.
we have kind of amusement parks in on space. Amusement
Oh,
parks on space would be the next level of machine learning, and that's
mhm.
really good. So constructive use of machine learning and AI needs to be propagated rather than propagating other nuisance things, or making nonsense things which would actually exceed human abilities. I don't see that to happen. Yes,
Yeah.
it will be there. As you know, ethical hacking and non-ethical hacking is there, and it's fighting each other. So the same fight would be with these two. Yeah.
Yeah.
So let's wrap this session with the learning outcomes which we would have while we would have a session in live scenario. We would understand the importance of data and information and knowledge transfer, understand various use cases and business scenarios in real world based on the domains which we have discussed today. I would cover all of that, 6 to 7 green domains which we have real-time use cases used while we discuss about this projects. So ideally, everyone would be taking up one single domain and try to find out how they can change or improve that case, the use case and the test case. In fact, the use case becomes a test case at the end of the session. So get hands-on experience on exploiting how analysis of and modeling of real-world business scenarios. It will give you a real-world scenario, and also it will give you a dashboard to work with in live scenario. Understanding machine learning and framework, developing and deploying machine learning models, develop analytical skills. Everything would be in a nutshell as a project. So ideally, we will project towards the end of the session, you will be asked to take up a project, and a live project experimentation would happen. You will have to build up a PowerPoint slide on the basis of that, and you will have to show on one of the tools, either Python or R or Excel or whichever tool you are comfortable on, and then mixing, embedding data science tools into it and finding out and building up a dashboard, a meaningful dashboard. That is the hands-on experience. So ideally, the benefits of the course would be corporate experience trainers like me and others will be taking up the session. Detailed content will be given to you. A weekly assignment will be given to you to solve live while we are talking. So hands-on experience was also, and also the live project experience, which would be demonstrated to you. You will be allowed to present a project at the end of the day. Resume preparation and guidelines and interview skill guidelines will also be given. The guidances which are given are real time, and the interview skill guidelines which are given are real time again. There are certain resume preparations guidelines which would help you in finding out certifications which needed to be done, and what preparation you need to do and what you need to include in the resume so that you have a better future. And I wish you all the best to get through these sessions and come up with full attendance. I would expect everyone to attend this session because this is a breakthrough science which is coming up. In the next 20 years, it's not going to die out. It's going to go ahead and create a landmark of a number of data scientists which would need to be produced.